When we apply differentiation, we determine the average gradient at a point or the gradient of the tangent at any point, and the rate of change or the immediate rate of change at any given point. Now, we've practiced the first principles. That's where you use that formula if x equals to f x plus h minus x squared. You know which one I'm talking about. We've just finished with that. And unless they ask you in a question specifically to use the first principle, it will be easier if you use the following rules. This is also why it's so important. These rules are there to make your life easier and to save you a lot of time. Before we then actually go and look at the rules, I want you to remind yourself of the basic principles of exponents. Now, if you look at these basic rules, you'll see that x to the power n over a can be written as the one that's in front here over a, and that x to the power n next to it. So if you get an example where we use real numbers, x to the power 2 over 3, there's a 1 in front of the x to the power 2, so it's 1 over 3 times x to the power 2. Here we've got a over x to the power n. To take this x to the power n to the top, to take away this fraction, you're going to take your x to the power n to the top. The x stays the same, no change in sign, but the n changes to the opposite sign. See here, you've got your example, 3 over x squared. So you can bring this x squared up as x to the power minus 2. Yeah, a over b, x to the power n. The a over b stays the same. Those are just numbers. And the x to the power n moves to the top as x to the power minus n. Same here. A, b, x in brackets to the power n. That makes both of them n. So you will bring both of them to the top and make them still in a bracket to the power minus 1. And that's exactly what happened here in your example. If you look at this one, here you've got a square root at the bottom, or a root. You don't really know what that n's value is. So you leave your a as it is, and you're going to take away your root first. So it will be x to the power m divided by n. But because you're going to bring it up, it will be x to the power minus m over n. Yeah? If you've got a number under your root with an exponent of 1, because if there's nothing, it's always 1, you leave it. So you leave that inside your root bracket, see there? But this one where there's an exponent that's more than 1, you can take it out. So it will be x to the power m divided by that number there. Now let's look at the rules. Your first rule says, if you've got fx is equal to a, any number, x to the power n. Now x is in any variable to the power n, the number. So you'll take your f with a accent. X is equal to a times that n, x, that n minus 1. What happened? The exponent, that one there, is multiplied by the coefficient, the one in front of it. And the exponent becomes 1 less. If you look at rule 2, here fx is equal to ax. Then the derivative of fx is equal to a. What happened here? Let me explain it to you with this example. 12x is the same as ax. Now that x is to the power 1. Now 12 times 1 is 12. X to the power 1 minus 1 is x to the power 0. Therefore, this becomes 1, because anything to the power 0 is 1. 12 times 1 is 12. The third one is fx is equal to a. So there is no x or anything that is a variable here. It's just your number. And if there's just a number, it always becomes, the derivative is always 0. What happens? So you've got nothing to multiply 3 with. So what is nothing? Nothing is 0. 3 times 0 is always 0. Before we continue to the examples, just remember that the derivative fx is exactly the same as d over dx. It says the same thing. And capital D with a little x. It's still the derivative of fx. Example 1. Determine the derivative fx if fx is equal to 4x to the power 7. Now 4x to the power 7. You take the 7 and you multiply it with 4. That gives you 28. And then you say x, 7 minus 1. So the derivative fx will be 28x to the power 6. So example 2. Determine this, which is the same as that one, if this is that. Okay, then you'll go and say 2 pi over 3 x7. Now what you do is you multiply this whole thing with 7, and then you'll get that is 14,66 or 14,7, depending on how your calculator is set. And this is x to the power 7 minus 1. So this will become dx is equal to 14,66 x to the power 6. Example 3, determine dx, where there's in brackets 14x to the power 1. Now we know this is the same as that. So it will be 14 times 1, because that's to the power 1, x 1 minus 1. So dx will be 14 times 1 is 14, and this is x to the power 0, so it's 1. So 14 times 1 gives me 14. So the answer here is 14. The next one, determine the derivative of x if fx is minus 1. Now remember what I said, if there's no x or anything, this always becomes 0. Again, this means the same as that would have meant, okay? So I've got fx is equal to a. A is any number. Remember again, any number with no variable will be 0. It's a rule. You have to remember that. Yeah, you've got to find the derivative for that. So you've got 1 over 5, that is the same as what's standing there, x to the power 4. So I'm going to multiply 1 over 5 times 4, and that will give me 4 over 5. I also say x, 4 minus 1, and that gives me x to the power 3. So dx is 4 over 5 x to the power 3. Example 7, determine the derivative of x if fx is equal to 3 over x to the power 3. Now remember, we don't work with a fraction. So we'll say 3 over x to the power 3 is the same as 3x to the power minus 3. So now we say fx is equal to 3x to the power minus 3. So the derivative of x will be equal to 3 times minus 3 gives me minus 9. X to the power minus 3 minus another 1 gives me minus 4. Okay, the first one, that is now 3x squared minus 2x plus 1. Now, the minute there's no exponent, that becomes 0. Okay, this one will be 3. This one will be 3 times 2, which is 6. X, 2 minus 1 will be 1. Minus, the 2 times 1 is 2. And x will be x, 1 minus 1, which is 0. X to the power 0 is 1. 2 times 1 is 2. So that is what it starts off as. So the dx will be 6 x to the power 1 minus 2. You don't have to write that 0. It's just extra ink. The next one, determine the derivative of fx if fx is, and let's quickly write it down, 4x to the power 3 minus a half x squared plus 5x minus 9. Okay, the 9 we know will be 0 because there's no variable. Let's start at the front. 4 times 3 is 12. X, 3 minus 1 is 2. Minus 2 times a half is 1. 2 minus 1 is 1. Plus 5 times 1 is 5. 1 minus 1 is 0, so that x falls away. So the derivative of x will be equal to 12x squared minus x plus 5. Okay, what happened here is they gave you fx is equal to that. And now they want you to determine when the derivative is 3. But if you remember, when we were working with the first principle, we would always find the derivative of x first before we replace the 3. So this is exactly what we've done here. We said 3 times 3 gives me 9. 3 minus 1 gives me 2. 7 times 1 is 7. 1 minus 1 is 0, so that falls away. Minus the 4, which falls away because there's no x there. So now we say, okay, 3x squared plus 7 is my derivative of x. To get the derivative of 3, I replace the x with a 3, and that will give me 88. If I look at this one next to it, here fx is equal to 3x plus 5 in brackets squared. So we've got to go write it twice and multiply the bracket away. You know, forky backy. That will give you that fx is equal to 9x squared minus 30x plus 25. Now that means that the derivative of x will be 9 times 2 is 18. x, 2 minus 1 is 1, minus 30 times 1 gives me 30. 1 minus 1 is 0, so that falls away. And the 25 has also not got a variable, so that falls away. So this is my derivative of x. Now they wanted the derivative of minus 2. See here? So you're going to replace minus 2. So it's 18, and in the place of x will be minus 2 minus 30. And that will work out to minus 66. Go try the exercises that follows. Do 3E, 3F, and 3G. I will speak to you guys again on Friday.